tagline of Eduhub community. The tagline of this community is "Let's take you forward." After joining this session, you can learn each and everything about CAC and all the roadmap things. Okay, this particular session is association with University of Engineering and Management UVM Jaipur, Geeks for Geeks Student Chapter Lovely Professional University, Google Developer Student Club BIT Deoghar, Cosmic Coder Community, Hack Hoodie, Hack Club RAIT, GDSC BIT Jaipur, Code Dazzlers Community, Codit Community, Semicolon, CyberJang Community, and Innovation Institution Innovation Council, Algorithms Community, MANUU Coding Club, the National Institute of Engineering. So now I would like to hand over the stage to Neha Jha. Please, Neha, you can continue.
Thank you, Saita, and very good evening to everyone. So let's start the session. So you can have data without information, but you can't have information without data. It's the privilege of the community to organize seminars and meetings related to professional world and try to solve problems with their own efforts. DSA is one of the most hyped terms in the placement arena. Holding relevance to data science, statistics, databases, it is an organized way to store information. In the current era, where data is like an ever-growing tree, we need ways to arrange it and keep it updated. Today, we have with us one of the most experienced and knowledgeable person, Mr. Abdul Bari, sir. He is the top educator from Udemy and one of the foremost authorities of computer science, NBH Infotech CEO and a renowned computer science teacher, a leader with an extensive experience in computer software industry. I know everyone is super active to ask questions to sir, but now I would request sir to please share his knowledge and his journey in DSA field. Please, sir.
Yeah, thank you. I have to share my screen. Can you see my screen?
Yes, sir, it's visible.
So for increasing my productivity, what I do is I just write don'ts that I don't have to do all these things.
Shall I start? Is my screen visible?
Yes, sir, you can start.
Roadmap for CSE students. Good evening, everybody. Yeah, the topic is roadmap for CSE students. So what I know is, yeah, most of the students are from first year or second year students are there, right? Am I right? Yeah, most of the students are in your first year or second year, right? Not the passed out or final year students. Because I have framed my lecture, I have my contents are related to the freshers only, right? So somebody is using the screen, I think, in parallel. Now, roadmap means actually, if you're in first year or second year, and then you have 2 or 3 more years in your hand. So what you should do in these 2 years and what you should focus on. Like most of the students I found in
Sir, please unmute yourself, sir.
Yeah.
Fine.
In my career, when most of the time I have seen that the students, when they reach their final year, then they realize that the importance of all the subjects that they have already learned them in engineering, but they have learned it only for the examination purpose. So they are worried about their future, means worried about their own career, and they will have very limited time. Mostly it happens in 4th year, second semester. Now they are worried about the career and they will like to get some good job in good big companies. So this is the worriness that if they are not focusing in their 4 years of engineering, then they face a lot of problems in final year, or even after completing, most of the students don't get a proper job. So that's what this seminar is for, those who are still in first or second year. Okay. Now, the first topic that I'm going to discuss is what you learn in engineering. What do you learn? So I have categorized into three things. One is programming, and then computer science concepts, and also third one is problem solving. The first thing, in your first year, most of the universities in their first year, they teach C programming, C or C++, these type of programming languages they teach in their first year. Now, some students think that now we are in the era of cloud computing and we have the advanced languages like Python in that is in use now. Then why they are teaching us C or C++? The student gets confused here. But actually, C language is the mother of all the languages. We can take it as in high-level languages, means the languages which can be easily understood by humans. In high-level languages, C language is the mother of all. And if suppose you are learning just C++, then it means C is actually a subset of C++. So if you're learning C++, you're also learning C language also. So some universities, they offer C++ in their first year. So learn any one of this language. This is the base language. And I have a next slide to show you. Somebody is using the screen. If they are just moving their mouse also, it is drawing something on the screen. Because I'm using a marker here. Yeah, you can clear the screen from your side. Okay, back to the topic. Now here I have listed some of the programming languages like you may be studying in your engineering, like C, C++, C#, or Java, JavaScript, Python, HTML, SQL, PHP, Perl. These are I have collected these subjects from various various university syllabus. So these are the commonly taught languages in your engineering course. The first thing is C++. Right? Now C or C++. Now these are general purpose languages. If you take all these from C, C++ up to Java, these are for general purpose. They can be used for any purpose, any type of programming that you can develop a website, you can develop a standalone application, you can develop a cloud-based application, you can develop middlewares, you can develop various things using these languages. Now, sometimes this type of applications are also required. Device drivers. If you talk about device drivers, development of device drivers can be done only in C and C++. It is also called as a systems programming. So what is this device drivers? Like suppose if you are connecting a printer to your machine, then you need a driver to use that printer. So that driver software is written in C or C++. It cannot be written in Java or JavaScript or Python, any of these languages. It will be C or C++ along with some assembly language. So from this, I can say that the core of your computer science, is developed in C language, C or C++. Then if you come to Java is having some limitation. It cannot be used for device drivers and all. Excuse me. Then JavaScript can be used for just front-end development. You can develop web pages using JavaScript. But recently they have started giving support for JavaScript for server-side programming also. It is also useful for server-side. It is famously known for a language used in developing web pages, for bringing interactivity in web pages. Now, there is a technology called Node.js. That Node.js is used for developing server-side applications also. Likewise, HTML is for developing web pages. Python is general purpose, but it cannot be used for mobile applications. SQL is just for database, for accessing database or querying the data from the database. PHP, Perl, they are again useful for server-side programming. Now, I have given the overview of some of the languages and their usages. So now, the main important point that I have to communicate here is that, see, learning programming language is different thing. And in my first slide, problem solving is another thing. These two things. Mostly students get confused. They try to mix programming with problem solving. Actually, these are two different things, remember. Learning programming means learning the syntax of a language. So what does a language contains? Language contains the features like data types, conditional statements, operators, then you'll have loops, then functions, classes, so on. These are the things that are found in a language. So when you're learning any programming language means you are learning what are data types, what are operators and all. If you have learned that thoroughly in one of the language, let us say C language, then learning Java is not a difficult thing for you. And learning Python is not a difficult for you. So learning any one of the programming language is sufficient. So among these first four, if you ask me which one I should learn, sir, so I say learn Java, completely, everything from Java, learn everything from Java, focus on that. All right. Now, one more important point. If you are learning Java in your second year, first semester or second semester, if it is there as a part of your course, then you should learn Java in that semester only. Not just the syllabus given from the university or not just mugging up the solutions given by your teacher, but you should learn Java and become expert in Java within that semester only. Usually a semester will be of 3 months. So in that 3 months, if you have 3.5 months or 4 months, whatever it is. So in that semester, if you have one language means you should get master in that semester only. If you keep it pending, then you have to do it after completing your engineering. All right. So if already Java is completed, now still you have a time in this semester, apart from your curriculum, apart your syllabus, you can also continue learning Java by yourself. If you learn C, C++, okay. And second thing, you can pick up a C++. You can pick up C++. Java or C++. C++ will be a little tougher on side. Java will be damn easy. So you can easily learn all the concepts of programming from Java. So syntax and the concepts related to programming. This is what you have to learn. Next, I'll go to the third slide. I'll go to the third one. Now, next is like student thinks that if suppose I am teaching C++ to you, I have a course on C++, or I am conducting a classroom session, right? I am teaching C++. You think that I should teach you teaching you actually programming means I am teaching you what just syntax and syntax, how to write conditionals, how to write use operators, how to write loops and all. I am teaching this thing, but problem solving is a different thing. Problem solving is a different thing. I cannot teach you problem solving. I cannot teach you problem solving. Now, most of the students, like there is a hype, there is a trend going on that is competitive coder, competitive coder. Coding. Now, most of the students ask the question, how to become a competitive coder? So there is no answer for it. There is no answer for it. If you are asking this question means you can never become competitive coder. And that's what I believe. A competitive coder, he knows already everything. Then he will simply smoothly move into competitive coding. Now, I cannot teach somebody, pick up somebody and teach him, this is how you should learn competitive coding. No. Why? Listen, there is a reason I am telling you. Competitive coding is related to problem solving, not related to programming. It is not related to programming. It is related to problem solving. Then how actually the problems are solved? Do we need programming for solving the problems, or do we need mathematics for solving the problems? What we need we need mathematics for solving the problem. How good you are in mathematics? Now, if I ask like 100 students, 300 students are there, if I ask how many of you hate mathematics, definitely more than 250 students will raise their hand, we hate mathematics. So if you hate mathematics, you cannot become competitive coder at all. If you're saying I hate mathematics, then till now you have reached engineering means just you have cleared the mathematics subject. Just clear them for the examination purpose. You have studied them, but you have not really tried to learn the subject. So the point here is that I have listed all the subjects here that will help you develop programming solving, problem solving skills. And if you have taken mathematics seriously up to your 10th standard or even in engineering, then you are comfortable mathematics. Then I can teach you competitive coding to you. I can just guide you, because learning problem solving is a lifetime effort. It cannot be taught in 2 months or 3 months. It's a lifetime effort. Imagine in your most of the universities offer mathematics subjects like maths 1, maths 2, maths 3, maths 4. Like in South India, we have four subjects they have in mathematics, just in mathematics. So already up to 12th standard, you will be learning mathematics. Then what is the reason again teaching same mathematics? And most of the topics are just like revision, like probability, statistics, and calculus, differential equations. Like these topics are mostly revision and discrete structures also. Some of them are a repeating topic, revising. Why they are revising all those the same thing once again? What is the benefit? So most of the students don't find its usage. They feel like it's a burden on them. But actually those are the subjects that actually teach you how to solve problems. Your brain, your mind will get trained in solving the problems. So when it comes to competitive coding, you start doing it by yourself. Nobody has to teach you. Just somebody can guide you, that like do this first, do this next, do this next. They can guide you. Like I am guiding you that first you make sure that you know any one of the programming language. Is the first thing. And once you know programming, when you can write the code, any type of code by yourself in some language, then when it comes to competitive coding, you pick up any problem and you can start solving it. Because solving a problem doesn't require a keyboard work, it requires a pen paper. It requires a pen paper. You have to use pen and paper for solving the problem, not the keyboard. Once the problem is solved and you got a clear idea and you got an approach for the solution for the problem, then you can start coding it. You can start coding it. That's it. So problem solving, for getting good grip in problem solving, please focus on these subjects, and how to study this subject, I will tell you. For every subject, you'll find videos available online in the internet, in YouTube. A lot of people have published their contents on various subjects. So you find the videos. So try to watch the videos first. And then you may find some simple notes or PDFs available in internet, like notes. So follow that notes. Then third step, you pick up a known book, a famous book for all these subjects. Whatever the subject is there in your semester at that time, okay? Pick up the famous book or prescribed book from the university, pick up that book and you go through that book. Page every means you should be much familiar with that book. Spend more time on book. So try to study the subject from the book itself and make that book your friend, right? So even after 5 or 10 years also, if you just look at the book, you can recall everything that you studied. So studying from, I don't believe the new generation is learning from the videos only, but that is not a good source. That's not a good source. That is just for getting awareness, just getting awareness. You have to do pen and paper, use pen and paper. Unless you do that, you cannot learn by yourself. All right. So when you study something from videos or from video courses, the next thing you should learn from the book also. All right. So this is about the problem solving. You can just look at the subject names. I have not I'm not reading them out. You can read it for yourself. Mathematics subject, probability, calculus, and lastly, compiler design and numerical analysis. These are the subjects that help you in learning problem solving. The next thing, computer science concepts. See, you have one problem. You have solved that problem using mathematics, and you have a solution. Right? Then this solution you will convert into a program. Convert into program. Now this program runs upon what? This program runs upon operating system. Operating system runs upon what? Your hardware. And your hardware may be connected to network also. Your hardware may be containing database also. All right. So now you can see this once again. You have a problem, you solve it using mathematics, you have a solution, then you have converted that solution into a program. Now, if you see from this side now, a hardware contains a disk or a database, files, and network connected. And then over the hardware, operating system runs like Windows or Linux, Windows operating system or Linux operating system. Then upon that, your program runs. So you should know where your program is running and how a program can utilize network services, how a program can utilize storage services. The program should know how to utilize the resources available on the system. So this is your computer system. This is your computer system, right? Related to this computer system, there are a lot of subjects again in your engineering, like computer organization and architecture. It's related to the hardware. Digital logic design, that is related to the hardware. I write down here. It's also related to hardware. Operating system, that lies in between your program and your hardware. So you have the subjects like some university, they offer operating system. And again, in final year, they will have advanced operating system. Then, okay, one thing I missed in this hardware part, that is main memory, RAM. I will write it as RAM in short here. So that is also part of your hardware. How to utilize RAM for storing your data is data structures. Then there is network programming, software engineering, and computer forensics or computer graphics. These type of subjects are taught in your engineering. So every subject is important. Every subject is important. You cannot ignore, you cannot take any subject easily. Now, one important thing. Okay, on this subject, how to prepare this subject? Same way. Watch YouTube videos, okay? Get the notes, study from there, then pick up a book. Finally, you should learn something from the book. You pick up the famous book or the prescribed book from the university and study from them. All right, the same way. For all the three things, you should follow the same approach. Just get the idea first from the videos, lectures and all. Then next, you prepare from the book. Now, okay, problem solving. Second one, this one is there, right? I was talking about this one. Now, learning all these subjects is as important as other ones, because unless you understand your computer system, how you can write the programs? So you should understand your computer system. All right. Now I have three elements here. One is problem. I'm drawing it again. Then next is program. And one more is computer system. Problem solving, you need mathematics. Mathematics, physics, whatever it is. So wherever math is applied, you need that one. Then next thing is, for converting this solution of this problem into a program, you need to learn any language like C, C++, any one of the language, and you should know the syntax. That means you should know the syntax, how to use it. Then where you are using it over a computer system, you should have the thorough knowledge of computer system. So these are the subjects related to your computer system. All right. Now, one important thing I'll tell you. See, writing the exam and clearing the exam is one thing. Knowing the subject is another thing. Knowing the subject is different from writing the exam. For writing your exam and clearing the exam, just one day preparation is sufficient for most of the students. But for learning the subject, you have to spend a lot of time on learning the subject. All right. So apart from your college hours, whatever the college hours are, rest of the time you should be spending in preparation only, right? Learning only. Now at college itself, there are a lot of activities for entertainment, enjoyment happens at the college itself. Then if you do the same thing outside the college also, it's useless. So at home, you should spend much of your time in studying all these things. So as you are in first year and second year, I have shown you the importance of these. Now, is it not possible, like some question, like one of the question I just raised here? Okay. Why engineering colleges are teaching all these subjects? Why can't they just teach, I'm using this slide here. Why can't they just teach first semester C and C++, then second semester Java and Python? Then next they teach cloud computing, right? They teach cloud computing, then they teach Android. And then next they teach AI, what is AI and machine learning. Can't they just teach these things because these are the things very hot? Actually, these are all technologies. These are all technologies. And if you want to learn Android, just 1 or 2 months is enough. You don't have to do 4 years of engineering. All right. And if you take your engineering subject seriously, then all these are nothing. See, as a student, when I was a student, we learned Perl. Not even C language. Even C language was not there in our syllabus. Just one subject called programming languages was having 5th unit as a C language. And even there was no lab for that. There was no lab for that subject. Later, they introduced lab for that subject. So the language that we learn is different. Right. So nowadays, the other languages, advanced languages are there. So just imagine a person who studied Perl in his college. Now he can teach anything, or he is understanding everything. How it is happening? Self-learning, self-learning. Now coming to the next point. When you go for placement, do they ask you about all these latest technologies? Unless and until you have done some specialization in them, they will not ask you all these things. They will ask you the basic concepts from these subjects only, from this one, and from this one, from these subjects. They ask you questions from these subjects. I'll just remove it, clear it off. Now, why the companies ask the questions from these? Why they conduct interviews from these subjects only? Why they do? They want to know, are you a good learner or not, self-learner or not? If you are a good learner, then the companies will hire you and they will train you. On job, you will get trained. They may conduct a special training session, or also by working along with your seniors, you get to learn the things slowly. See, a fresher who have just passed out, we cannot expect a lot from him. We cannot hand over a big project or crucial project in his hand. We cannot hand over to him. Right? So then fresher should be what? Fresher should be a good learner. So if he have learned these subjects thoroughly, if he has taken these subjects seriously, then definitely he will spend. Definitely he can learn at job also. On job also he can learn from his seniors. That is the reason. See, some companies, they don't utilize the things at this core level, but their usage is different. But they ask these questions. They frame the questions from here only. So it is more like Viva. Interview questions are just like Viva. So in your semesters, if you are good at Viva and your Viva examiner appreciates you, then it means you will get a good job in big company, definitely. All right. So interviews are more like Viva for freshers. And if you miss a chance as a fresher, if you could not get a good job as a fresher, then you have to learn all these things. You have to learn these things. I have listed them. The latest technologies you have to learn. Why people learn these things? That after learning this, they show that I was working on this. They show some fake experience, or if they join somebody, like they get attracted to the people, like they will say, we will hire you, but you have to pay us. We will train you in 6 months and give you certificate also. We will give you experience certificate also, and then you can join any company. So that's how people are, means they are doing the business like this. So some people are caught, some students are caught into those hands also. So the reason is they could not get a job in just after final year. The reason, they were not good at these subjects. They could not answer the questions from this subject and also the programming subject. Nobody asks related to mathematics. They don't ask questions related to mathematics, but they definitely ask the core subjects of computer science. They ask the language related questions, right? They want to see how much you have. Somebody has raised hand. Yeah, tell me. Somebody has raised hand. Do you want to ask any question? Am I audible? Yeah, Ankit.
Yes, sir, you are audible.
Ankit Kumar. Vivek Verma, do you have any question? No? Okay, let us move ahead. Acha, you have written the question. Do I have to check chat? Sir, one doubt. That okay, I will be attending all the maths classes, all DBMS lecture, all OS. But sir, what is the use of physics in our placement? Because you have mentioned physics. Very good question. Okay, wait. Don't flood with the questions. Let me answer this. Okay, unmute. Who is asking this? Gaurav. Okay. Any more question? Recording on. Okay. Oh, sorry. Computer networks, there is a lot of physics. Yeah. See, physics is involved in your making of your computer system itself. Yeah, networking also physics is involved. Right? Maths, physics, chemistry, like these are the three things that does everything. Like when you go to your chip level, manufacturing of chip level, then definitely chemistry is involved there. And how the system is designed, your computer system is designed, the machine is designed, so physics is involved there. So there are many formulas, there are many things there that are just in the form of mathematics only again. Physics in the form of mathematics. So I'm not saying that focus on physics. It is so usually taught in first year. Physics is taught. Why it is taught, I'm telling you. Okay, I'm not saying that leave everything and start learning physics. That is not the point here. Okay. So physics is also taught in South India, like in Hyderabad, most of the area cities, they have physics also in first year, chemistry also in first year. What the hell, why they are teaching that again? Because that is useful for all the engineers. Most of the time, first year of engineering is common. So they make everybody study those subjects. So but computer science students, they feel that, computer science students feel that we are into programming only. What is the use of this? So that's what I am saying, that all these subjects are useful for you. They will make you learn problem solving. They will make you learn problem solving. Okay. So let us go ahead. Can you clear the screen? Somebody has written on the screen. Let me check if I can clear it. No, it's not getting clear.
Ashutosh, are you there? Ashutosh, if you can, control the thing.
Yeah. I think it's visible to everybody. Okay. Let us continue. Career options. Now in this, first one is some of the career options I have given. The first one is web development. Web development full stack means front end and back end together. Now in this site, do you require programming on front end? Very little. A lot of tools are there, just drag and drop and develop your front end. Very little of programming is required. Now, do you require programming at the back end? Yes, you require enough programming required at the back end also. So at front end, programming is not much required, but back end programming is required. So here the programming is involved. All right. So if you're focusing on just on competitive coding, or you are trying to become a good programmer, then if you are becoming a web developer, then your job may be writing the programs at the back end. And this backend, today's backend has become a cloud. Earlier, it was just web server or web services. Later on, now presently, backend is nothing but a cloud. So you are doing cloud computing, it means. Now, next is database administrator. This role is related to managing database or administration of database. So databases, you will be studying in your coming semesters, maybe. So I'll just skip a little bit about this one. Data is the core part of your application. Without data, there is no use of application. So data is mostly kept in the tabular form. It is organized in the tabular form. There are more methods of organizing them. So one of the methods is organizing the tabular form, that is called as relational data. Relational database. So relational database. So when the data is organized in the form of tables, multiple tables, and the tables are linked together. Now DBA does now have the knowledge of everything about the databases. All right. So I can just tell you a little bit about this one. So DBA job is related to database. That's enough. Now programmer. Programming means application programmer. that a person is using Android or Android application he is developing, or iOS application is developing, or standalone desktop application is developing. Now, one of the role is what? Here also programming is involved. Here also programming is involved. Okay. Now, DBA programming, SQL is required. A little bit of programming is required, not much of programming. All right. So I am telling you the point. What I am trying to communicate here is that no doubt you have become a good programmer. No doubt you have become a good programmer. You have studied the subject thoroughly. You know the language perfectly. But it doesn't mean that in career also you need to write the programs always. It's not necessary, because there are different job roles, and they have some of the job roles require really programming knowledge, and you need expertise in programming. But for getting a job, you should know programming again. So which level of programming you should know? Student level programming only. Whatever you learn in your course, only that knowledge is enough. Right? You don't have to know, you don't have to be a master in programming. Whatever you learn in your syllabus, that is sufficient for the companies. All right. So overall, what I am trying to say is focus on the subjects. Focus on the subject. See, the subjects that are there in a semester is building your career. Right? Yeah. Consistent. Okay. So those subjects are making your career. You don't have to study anything extra other than engineering subjects to get a job just in one attempt, a good job or job in big company in the first attempt itself. Otherwise, you have to struggle with all the other technologies. You have to learn all the things. This one, what I have mentioned here, some of them I have mentioned anyway. Now, graphic designer. Graphic designer is more useful for developing front end of the website. Front end of the website, right? Now, data scientist or data analyst. Nowadays, the internet is full of data. Vast data is there. So, analyzing over that data for solving business problems or giving solutions or giving analytical results. Now, here also a little bit of programming is required. Testing, you don't have to have a good knowledge of programming, but you should have a knowledge of testing. So definitely testing is not taught in your engineering, right? And graphic designing is not taught in your engineering. And in your engineering, they will not make you data scientist directly. Maybe some subjects are there, but directly they are not making you data scientist. But the subjects that you have studied will help the companies to make you work upon these technologies with a little bit of training. And you can learn them by yourself, right? So these are the different roles I have mentioned here. And again, game developer, this is a programming part again. Network or cloud architect, programming is not much required. Software tester, knowledge of programming is not much required, but overall knowledge is sufficient. Now imagine, if you are aware, most of the jobs are for testers, testing job. Many people, after completing their engineering, they join testing. They easily get the job there with a package of 1.2 or 1.5 LPA. They get the jobs there. That is the easy and the quickest job. Reason, you don't require much skills there. That is the reason. That is the reason. And while working, then you realize that really this is nothing but a routine job. Even without doing engineering, you can do it. So the job should be such that your engineering, all those things that you have learned should be useful. If you if a person is doing a job and he feels that unnecessarily I learn all those subjects in engineering, means he is not working as an engineer, definitely. Now coming to the next. Yeah, this was the topic actually. In the beginning, this was the topic. And that is data structures and algorithms. This was the topic. So I have little time, just I will tell you brief on this one. Somebody is writing on the screen. Can you please clear off? It's gone now. Thank you very much. Yeah, see, data structures. Now, what is the importance of data structure? That I'll explain you. See, I have shown you this diagram. Okay, from the top I will show you now. This is a program. Program runs over the hardware. and this is OS is there in between. So program is running over here. Now hardware involves main memory also, main memory. Okay, the program runs. The program runs when it is loaded inside the main memory. When it is kept inside the memory, then only program runs. So program runs over the hardware. All right, over the hardware. Now a running program in the main memory, when the program is running, it uses data, because program is nothing but step-by-step procedures that is performed over the data to get the results. Step-by-step procedure for that are performed over the data to get the results. I am giving this definition now, right? So program is a step-by-step procedure. If you ask what is algorithm, that is also a step-by-step procedure for writing a program, for solving a problem. So program is also a step-by-step procedure. There is no use of procedure if you don't have data. If you don't have data, so program definitely requires data. Program contains two things. Now program is equals to, I say like this, program is equals to instructions plus data. Now program, where does the program run? Inside the main memory. I'll draw a bigger picture here. Inside the main memory, program runs here. All right, so inside this main memory, program is there, and also your data should be available inside the main memory only, inside the main memory. So during the runtime of a program, how the data is organized inside the main memory, the arrangement of that data is called as data structures. Arrangement of that data is called as data structures. So the data that is used by program is called as data structure. So a data structure is a core part of a program. Without data structure, there is no program at all. There is no program. It's a core part of the program, data structure. So if you don't know data structure, it means you don't know programming. If you are not good at data structure, it means you don't know programming. Because see, okay, next I will show the slide. This is the last slide. Now, these are the algorithms. What are algorithms? Algorithms are nothing but the procedures for solving the problem. I'm not going to teach you all these algorithms, just I have given a list of algorithms, types of categorization, and names are there. So these are the problems. Algorithms. Algorithms are the step-by-step procedure for solving a problem. Now, why we say algorithm? Algorithms are not written using some programming language. Algorithms were existing before computers came. Algorithms are existing from thousands of years. Right? Algorithms are already there for solving the problems. Those algorithms were nothing but in the mathematical form, right? Mathematical formulas were there. Now, when computer came in, we started converting the known algorithms into programs, converting algo to a program, algorithm to a program. Now, what is required when you are converting an algorithm to a program? The steps in an algorithm, the steps in an algorithm become instructions of a program. Then the data utilized in this algorithm becomes data structure here in the program. So without a data structure, you cannot solve or you cannot write any algorithm. You cannot write any algorithm. All right. So data is very important. Now I'll give you some idea. Here, you can see that one of the problem I'll pick up. Prim's algorithm. Prim's algorithm. This requires a graph. How do you represent a graph in your computer system? There's a connected graph and the vertices are there. 1, 2, 3, 4, 5. These are the vertices and they are connected like this. How do you represent this? This is on paper, but how a program can see if it is on paper, then you can use an algorithm for solving it. Who will follow this algorithm? Human. But program, your computer. See, I'll make it simple a little bit. Let us understand this. We humans can solve the problems using pen and paper. We humans can solve the problem using pen and paper, right? Then we define algorithms which are used for solving the problem. So definitely those steps are done on pen and paper. Same thing we want our computers to do that. So we should give this data to the computer system or to our program. If you want our computers to do the same thing what humans are doing, then you should convert this algorithm into a program. And the program needs this data, definitely. So without data, there is no use of program. How you organize the data? You use data structures. Here are the data structures. Like I have shown you one graph. So graph is there here. All right. Now just you see the names of the data structures. These are the data structures that is taught into 1 or 2 in most of the universities. And if you have not learned data structure, still you have a time. Still you have in the time. You have vacations also. In that you can revise all the subjects that you have missed them. Every subject is important. And the bottom line is that I end here. The bottom line is that every subject in engineering is important. So take it seriously. You don't have to worry about the job. And even if you don't get a job, you can create jobs. You can create jobs. If you know the things, then you can create the jobs. Otherwise, see, one more point I'll tell you. Those who know how to work for themselves, they can create jobs. If you don't know how to work if I don't know how to work by myself, then I need somebody's shelter. I will look for the job. That's one. So we stop here. If you have any questions, you can ask. Hope you have enjoyed the session.
Thank you, sir. From the audience, if anybody is having questions, please, you can put it on the chat. If any question more from your side.
Okay. Chat, I will open up. Okay. They are flooding in. I cannot catch them.
You can read. Neha, you can read if you can.
Yeah.
One by one. Yeah.
So there is a question that how to be consistent with DSA. Like we have to cover a lot many topics, and the consistency is the key. How to achieve that?
No, actually, some subjects are there that needs practice multiple times. Multiple times. Like as a student, I'll tell you what I used to do. Whenever I was free, I used to write a program for linked list. I used to write a program for tree, station of a tree. Not just one time. First time I have studied it. But whenever I feel like writing a program, I used to write on the same program once again. So as a student, you have a lot of time. So for being consistent, you have to practice the things that you have already done. So that not just here, not your brain should remember it, your fingers should remember the program. Right. So if you're even if you're in sleep, you should be able to write on the code. So for that, practice is more important. So not solving a new challenge every time is not important. You don't have to think of solving a new problem every time. You solve the same problem again and again. That is sufficient. And it gives you the idea for solving a new problem. Because what happens is, when you pick up one problem, you understand it a little bit, not everything. You believe that I have understood thoroughly, but no, you will be knowing a little bit of it. If you learn it once again, you will get the more details of that. If you learn it once again you get the more details of that. And if you are going more deep in one of the problem, then the rest of the problem become easy for you. If you know the problem solution superficially, then the next one, if you are going on, that will also you'll solve it superficially. So depth is more important. So if you are going deep into one of the topic, then you can carry on with the other topics very easily. Okay, there are a lot of questions are there, I think. So you can ask the questions in, there are different type of questions.
Yes, sir. Even one question.
Again, I'm telling you, if you are asking competitive coding means you can never become a competitive coder. You start programming, you yourself feel that I am competitive coder. Nobody has to give you a label as a competitive coder because it involves programming, problem solving skills. See, one thing is there. I'll give you a simple example. One simple example. I am a cook. Okay, I am a chef. I have learned making different dishes. Right? I have been working for 10 years, suppose. Now I have good knowledge of cooking. I can create a new dish. With my experience, I can create a new dish. No, other way. I am not a chef. I am not a cook. I have never boiled any egg, or even I have not made a tea at all. I don't know anything. Now I have tasted one dish. You give me one dish. I want to make that by myself. Can I make or not make? Just tell me. Neha, can you answer me?
Yes, sir, you can.
No, you means keep yourself there, not me. Keep yourself there. You know nothing about cooking, but you like one of the dish. I gave you one sweet or something, some dish, and you love the taste, and you got interest in cooking now. Can you learn or not?
Yes,
Yes.
sure, for
But
sure.
for making that just that one dish, just imagine how many things you have to learn. You never cooked at all. You never cooked at all. Now, for this dish has impressed you so much that you want to make it by yourself. Just imagine what are the things that you have to learn. Is the curve easy? Learning curve easy or no? No.
No.
Starting from the how to start a stove, gas stove, you have to start from there. You have to start from there. So same way, person coming in final year and saying that I want to become competitive coder, how to do that? So it is just like he like one dish and he want to learn how to make that dish. And he know he's zero in cooking. He's not a chef at all. So that's what is competitive coding. That's what it. I'm not discouraging or I'm not even encouraging about it, but I'm showing you the reality that competitive coding means you yourself feel that I'm chef. So same way you feel that I am a competitive coder. And if you try to go behind that one, then you have to relearn a lot of things. Anyway, if you are joining any competitive coding, relearning also helpful, but it's not an easy thing. Don't lose, don't get disheartened. Keep on struggling, and you can become a competitive coder. There are many websites who are trying to teach competitive coding. There are many people. Like I have one of my course data structures in Udemy. I never claim that it is for competitive coding. I claim that it's a general purpose. Whoever want to use, they can use it, and it's being used by industry people also.
Yes,
so that's
many
all.
were asking for the many were asking for the course also, which course to follow. So you can definitely check out Sir's Udemy's course. That is
you
for
can
everyone.
check. Actually, you have to follow not just one course. You have to follow multiple courses. Some topics may be good in one course. Some topics may be good in some other course. Some courses having some extra topics. So you have to follow multiple courses.
Okay, sir.
Okay. Thank you.
Okay, thank you everyone for joining. Thank you, sir, and sorry for the inconvenience caused at the
No,
starting.
actually, at the starting, the problem was from my side. Suddenly, in my office, this internet stopped working. There's a problem with internet, so I am using my friend's office now. I have carried my laptop, writing pad, mic, everything, and I came here. Now here I'm working from here, delivering from here. That suddenly it has gone out.
No problem, sir. No problem. Thank you for
joining. That was the reason
joining.
it was.
And that was really a wonderful session, a detailed explanation of all the topics that array linked list is still viewing and just going on everyone's head, like what to do, where to start. Okay, bye sir. Thank you, sir, and thank you audience for sticking with us, and you will surely be getting the recording. Thank you, sir. That was wonderful having you.
Thank you.
Even